Now I'm going to dive into my realistic algorithm here of the brain. You can see my long note here and this other one. Now I want you to read this here because it's focused on what I'm showing here. Now with the brain, you have the brain, the hierarchy, sequences in time of text data, or as you hear it or see it, the text, and sequences in time, and it efficiently stores them. They reuse each other, build the hierarchy of sequences, so bigger ones made of smaller parts, and as each one comes in one, you hear it word by word, phrase by phrase. They will go up on their own, activate it in time as it was heard. If you hear it again, it will want to activate it as it was like it was heard before, and wants to activate the same way. One by one goes in. Now, this fluctuating activations of going around does that now. So the brain is the sequences of text, and they build each other. And so the hierarchy, this is a hierarchy. The hierarchy in another video I showed on top, like dogs link the cat, and builds on those, like if this doesn't. So it's the same thing as this. It builds, sees what you're what, and then so dogs, cats, if they are both this and that, not. And they use the context handles to see, dogs drink, cats do this, dogs do that, on both sides. Closer ones mean more importance. You don't actually need the hierarchy, because the hierarchy, as the real human brain does in just a few passes in a second, it will go 7 passes around. All the pathways, the channels are leaking energy, and so if you hear zebras can jump, it will just activate this, no matter the typos or whatever, activate can jump, and then zebras will activate zebras, then zebras can drink, and then drink, and dogs can drink, and then dogs can jump. So loops around all the pathways, and then sees which is the most similar node. So what the brain does is it will see something, save it. So if it got can jump, but doesn't have this node, and then it hears can jump later, will build on top, build a node, and then if it sees something, say it got caught, dogs can jump, so it sees now zebras can jump, activates that a lot, and other ones, and zebras can jump, it will save too, even though it's very similar, because you can imitate it back out and remember it. You can store both, actually. So, human adults also can imitate too. It's the same thing as GPT-2 generating the rest of the story, just imitating the sentence, finishing it, or imitating purely. So now with that node saved, can save very similar nodes, even though they're too similar. The way it forgets is just if it's not activated enough or not related enough to a lot, it's too unique. Well, you do want to save it unique, but so if it's not activated enough or it's not related to the goal nodes, they leak dye potion. You install when it's the hierarchy is born, certain nodes you drop a red dye on. You can visualize it in the rendered here. So as it would think, the brain would think. So, the human nodes, the node food, humans, love. So these nodes you put the dye on, they will spread to related nodes, and you can watch it update its agenda question that talks to itself, imitate, finish, regenerates the rest of the story as it loops around, regenerate, activate, regenerate, and then it will finish the rest of the story, hear itself talking. So when a node is forgetting, if it's not activated enough, if it's not related to the goal node, channel not opening up, spreading energy and dye potion, and then if the node is too similar, because you do want to quantize them, save only the ones that are unique and very different from each other, because you can lower the node count cost even more. So with these nodes now, so zebras can come in, it's got different related words. It can still activate the node even though it's got related nodes, typos, or all conjoined, like cats can jump, and it's all stuck together like one word, it can break it apart as it enters because it activates each letter. Activate cats can jump instead of it doesn't have cats can jump. So they're all, it's not stuck together in here, so it can just recognize that one collage of letters stuck together. So it recognizes it, different word position, placement, or even if there's spaces between the letters, like cats can jump. So, typos, blanks, missing words. So no matter what you do, it will activate some more than others, the winner nodes. And the energy will activate, like both nodes, cut 100%. It cuts in half 50%, 50%, as long as both are 50%, 100%. And then the activation output will squash at 50%. If this one's got 0, or say 25%, it'll be 75%. So it keeps doing that. So it will, and it ignore, say you got 50%, 50%, then you got 100% here. It will ignore these, and this one's the most activated. Because, this one was 100% activated. So, you can have this one 100% activated, even this one. But it will just forget about those and then focus on the higher level 100% activated one. So then you activate this one, you hear it, focus on that one. So the energy is leaking, and you're building, you can recognize different ones. And the neural networks, if you look on the computer, they representation nodes they're made of can be activated by the front of a cat, the cat's nail, the side view of a cat's leg, the cat earlobe. Things that aren't even, the same node, different nodes, it can all activate one node. So it's a representation, really. It's not really one thing stored in the brain. But as you can see with the typos and the related words and the position, different new unseen data come in, it activates something, multiple ones. Like a whole bunch of different inputs can activate this one, and also this one, that one, some certain probability amount. So percentage, energy, activation level. So what's happening is, so now you can see, like I was looking at the Hutter Prize web page site, so you can see on that it compresses the data, and it's basically a generator like this, or like GPT-2. It looks at a context, because you look along the text, and you cut out this part, and you cut out this part, 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 and then you stack them all. You look at them. For all the last words, these are all words, like can, are, even this dogs can jump, just one big word. This is even a word here. And these are all like nodes in Word2Vec or glove, like the relational hierarchy I was talking about. They're all nodes, the vocab. And with the Hutter Prize, if you stack all the different possible strings of, like in the whole text, 100 megabytes, if you get every single 10-word sequence, stack them all, you can see every time the word the pops up, the, you got, and she was the, we seen the, but I would really like the, and so you have all the contexts that have the predicted at the end, like the parent node, grab the next word, jump after, you can grab the next word after, like take cats art, you can go up, grab the next word, animal. So with all the context, you can see all the ones that have the follow. So it can just chop out, compress the data for the Hutter Prize to like 15 megabytes, 14.8 it was, and it can still, as it's generating the chaining along, generating the whole thing, predicting one bit at a time, predicting each vocab word part, it will look at the last 10 or so or whatever. It will really consider a lot of them, like 1,000, like a transformer will, and it will, even though it doesn't have it stored in the brain, it will only have a few stored out of all the contexts for predicting the or other words, next words. So it will look, it can see a context that it doesn't have stored, and it will light up other ones that have the follow, so it can correctly look at it and say the comes next. So it correctly predicts the next word is the. So now with this, you can do the same effect as GPT-2 or the Hutter Prize algorithm winner, the one that got it down a lot compressed. So you can do the same thing with this. You can actually store all of them, and simply, because the compression was just, getting rid of some so that a whole bunch of things that you never even seen in your memory network will activate the correct one. That's what it was doing, is it wanted to make sure they activate the correct one. So you can do the same thing with this. Something come in, and it will activate the correct ones by the similar position or word or no matter the typo or the blank or the so it will activate the other ones you have redundantly saved that where the compressor just eliminated them. You can keep them, and it will still activate all of them correctly the correct amount. But what one idea I came up with is you can see an input which ones it activates in most, like activates this 90%, 89%, 78%, 60%, 20%, 3%, 2%, 1%, so 1%, 1%. So then you can, like, say you got 100%, 90%. So you can chop out every other 3 or every other 1 and cut the whole memory size in 4, because this activates this 99% and this 98%. You just need the 99% one and the 97 and the 90, not the 96 but the 95, 90, 93. So every other one, and you can chop out ones because quantized it. So you can, by looking at which ones are activated the most, you can basically chop out some if they're just activated by the same ones. So now to make this algorithm, you would, now how you can only chain forward, as you save it, it goes up like this, forward. So when you activate, it wants to activate the same way as you heard it before, from left to right, one by one. So, you can only repeat the alphabet forward, X, Y, W, X, Y, Z, A, B, C, D. You can't go backwards in the alphabet too easy. So what happens is that, not unless you do a trick you can with the brain here, using forward. So what happens is that the brain wants to go up, grab the parent node next word candidate to generate the next story word of the sentence. So wants to go up, go rightwards. So if you hear something, because here's a proof of it, if you hear hi there, the node hi there, or if you hear there hi backwards, it won't activate the node as much because it wants to activate the first one left node side. You're going to have 4 of these connected, by the way. It doesn't have to be 2. It can change it around to lower cost, learn segmentation. So it wants to activate the left one first and then the right one, and that enables it to make sure that they're in order. So if you're going to activate this node and you got T on the left or hi on the left, if you hear the there, hi there, it will activate there. It's going to activate this, but it's not going to activate as much as where if you heard hi there, and then so it has something about wanting to hit the left one first to open up the right one more, because it must come in and it activates it, but it doesn't come in, it's not opened enough from the left one opening. So that's why that we can only repeat forward the alphabet, because it wants to, the energy wants to flow forward, open up channels. So this thing would be talking to itself. It has the die on the node for the installed born with reward nodes for the reinforcement learning internal, like it's like a maze, you're going through a maze, it's learning to walk, but it's the internally the brain, you're thinking, describing the world. The humans made up the language of the words, every word in the English dictionary explains each other, so it's a small world network. Few steps you can get to any other node. Dogs drink, cats ran, I threw. So, you can just go around any other by a few steps. So these, like a small human world network, every friend knows other friends, bigger groups, businesses, or just friends can get to each one, small world network. So what's happening is the installed born with nodes like food and humans and love, these nodes are spreading to related nodes through the context handles, and it's generating those ones because they're pop-up questions when you wake up in the morning with a pop-up question, and so it's trying to answer the question, generate the next part to the right part side of it. And you can go backwards too in time, like if you're generating branching out, you might have to go back if it doesn't come in a good, safe outcome, like it deals with weapons or something. You want to go back and then go right. So they pop up question, agenda goal question, and if it goes right and it likes it, can update the question, update the reinforcement learning node, make a new goal. It might change its goal to like science or AI instead of stem cells. So these questions pop up on its mind, and it's generate back out, come back in, chaining forward, branching. Monte Carlo can do the branching, breadth. So it has these goals, the spreading of they pop up on its mind. Now, as you hear a sentence, they will pop up too, because they start holding energy from being activated, and they'll pop up. So, those pop up too. And so you could render this as it thinks, and it can learn online. You can see the activations go up, spreading, leaking, and it's interactive, it's simple, it's flexible, it's interactive, it's renderable, it's a white box, it can learn online, it can use the big data and generate more big data that's actually true-ish, just like GPT-2. It's truer data, and it can extract into save it what it generates, and even get more big data from the big data. So it's actually got some more extras in it if it learns online. And so you're basically so like I said, you can prune out some, something comes in and it activates a bunch of nodes and they're really too similar. Like it activates this 98%, 97%, so you can cut out every other one, so you just quantize it and you can lower the cost, no count. And so the brain would be basically has a train of thought, and it has different words on its mind, because you're generating a sentence and you're looking at the words in your mind for the last hour, like cars, rare words, scissors, doctor, so they are activation energy is letting up, and they are giving weight vote and the channels open up. And so, they're pop-up questions. It's on your mind as context, active context, short-term memory, and you can forget it if it deactivates, but it's still there, but just you forget what the password was. And so, it will, so you can watch it think, pop up a question and loop back in, one by one come out, one by one come in, one at a time as you hear yourself, I was walking down the street. So, and you can watch the die spread to the related words, update the question, can watch it build the hierarchy bigger, and you can watch it, go to the internet, research, find a source that's credible, and build the hierarchy bigger, add more data, or ask us questions about, is dogs cats, or can cats jump? And so basically, when you say cats are dogs, or you tell it ice is cold, that is node is very strong. It opens up the channels, so it's associated, even though it's just one observation of cats being near dogs. So you can say cats or dogs, because the node is very strong. So whenever you hear cats, it will leak energy to dogs, leak it, and it will activate it. Because you could say a lot of things like cats, ice, snow, this, that, but if you tell somebody cats or dogs, and if they believe you, it will open up a channel a lot more. So different nodes that are powerful related to the, like a friend, if you're credible too, like the node Joe, or just a node like you love, like food, and it will leak, a channel opens and it's wide open and it's leaking energy to related nodes. And so you can use it as a bumper or a booster. You can link it to other ones and help them out. And so basically the brain has the data, and it's got a agenda goal that pops up on its mind, and it's basically trying to do data self-recursion of the data, use the old data of the Earth, or the simulation model here as it's describing the world, trying to generate the data of the next generation, trying to evolve the data until it comes to equilibrium. It's basically trying to transform, just like a transformer, the data, and it's trying to evolve the data and generate similar data, imitation, and it's trying to generate the data that's like imitation of it, reflection, different analogies or angles of view of it. Like animals are smelly, or animals are best friend, or animals are creatures or organisms. So different angles of view of it, in different contexts. So based on the context, I mean. So the brain is trying to generate that data that's similar. It's trying to come to equilibrium. So it's trying to generate data that is similar. Now you see in this video here, I'm saying all this elaborate stuff. What is popping me up to say each word of this whole video is my pop-up questions have this chemical dye on a neurotransmitter, and it's making them pop up, and I'm canceling them out as I say each one. I know I said it, and I'm done saying it. So now I'm done saying all that too. So what happens is it's trying to generate see how I went back here to the last thing that's got the most recent activation on it and not finished yet, and I left off where I am, despite the gap. I took a break to tell you about something else. So back to this here now. So it's trying to generate the data evolution, the related imitation data. And so, like transformers in this, you need to find related, what activates a different unseen context activates the same node, and then it chains forward in time to see what comes next. Like you might say, how can I become immortal, or I need AI, evolution, nanobots. And you can go back, like, okay, how can I build nanobots? I need a lever, I need a hammer. You can go back. So it's kind of like, you go forward in time, then kind of like you change the question, start over again, and go forward in time, and you might go back in time. So it's kind of like, it's a Turing tape, you're going one word at a time in your brain forward, generating it, and that one node, as it goes forward, I was walking down and then you can recognize, go up, translate, grab the next word. So, like you got this sentence, translate it, go up, then go right, grab the next word. So it's kind of like, horizontal and vertical, like translate, recognize it, understand it, activate the node. Different similar ones activate the same node, a few of them, and you get what comes next. So it's kind of like trying to chain forward, update the question, agenda, sub-goal, and then like, find the right path. So it's kind of like an internal reinforcement learning maze for the brain to thinking. And it wants to update other humans too and tell them, make sure they learn the new knowledge it just discovered. So it's trying to update each node using all to all, and it also wants to do that in the brain, like update each other. So like, you have two humans, one learns one thing, wants to share it with the other. So it's kind of like they're all communicating, making sure that one has what it has. So it's kind of like, you have this node here, it wants to leak energy to nearby one's context handles, make sure they all have the same thing. So it's trying to leak energy, update a new question agenda. So if you have food might leak the energy to money, find out that money can get food, and then money to science to nanobots. So might find out nanobots is going to leaking energy to it, so find out nanobots can give you the food, and then that becomes the updated new agenda question that pops up on its mind. And so it's updating what's popping up on its mind, and long term, what's popping up, short term too, what currently activated behind it in the last heard words, so, or nodes, because these are all nodes, like, a document, they're all node words. So, and you can see vision is basically the same thing as text. You got the image, and you want to go image to frame to frame to frame sequence. Go forward. Cat, run, to bowl, drink, then go over here. Now, as you see in an image, you have the objects. Cat, run, to bowl. Now, if you look at an image, you see a collage of things. Like you might see in one single frame a cat, and in the distance a bowl, or in a door, and a little wrench, and a human owner. So all these objects in the image, they have a similar position and context. So you have the objects, the node, and you have similar positions. And then as you watch it, you see the similar positions, cat run to bowl, or cat to bowl ran. So different arranged position of the words. So it's the same thing as this. You have the objects, the words, and then similar positions. So it's just 3D. It's just extra. It has the 3D block, each frame of vision. The vision just has a second extra position in it. So it's the same thing. You have the like in time and space, you have the objects and you have this similar position. Now you might have like, not just the positions of the word is similar when you're activating a node from similar unseen input. Dogs can jump dogs. So you might also hear, where is the dog actually in the node? Where is it saying? Dogs are in the farm. So the farm or the store. So that's just the text. You don't need to worry about that. You just need to worry about the position of the word or node, and so dogs can jump really high. So you just need to worry about the position of it. Now, you might have and so dogs can jump really high, or you might have dogs can jump really high and so rearranged parts. These are relative correctly placed, but then the larger sum of the phrases are displaced. So that's okay, but it affects the activation a little bit. And that affects it. So the brain is just basically, because every single particle on Earth is really, it's all a collaborative context bag. So they're dependent on each other, especially to nearby local neighbors. So the context neighbors are very important. You can get to many different nodes from just a few steps away, but they are all, like in a dictionary, all depend on each other, and same for real life objects, which we describe in using the language of English text. So, and vision is also simulating I'm actually using vision when I'm simulating in my brain. I can actually see videos of things that's just extraordinary. I can see lines extend out and of text, and I can move it up, move it left, duplicate it, turn them blue. I can move them over here and make a whole bunch of links pop out, and then I can make a tree grow. I can do anything in my mind. I can see it. So it's kind of like a super simulator wonder world. So, but with the text, it is trying to, because they're all dependent on each other. So the brain is just trying to use all the bag of context to generate the future generation of data. So it's using all that context, generate more context from old data to new data, and the old data is the verification of what's correct, majority vote. So it is, the brain is dependent on all that context. So that's why when you are trying to spread that correct activations to the correct nodes in the brain, watch it jiggle around, come to equilibrium, and look for more data and repeat the research and development, R&D. That's why you want that energy, and you want the pop-up nodes that are always generating energy on their own. You want these pop-up nodes and energy and the neurotransmitter dye for the goal reward, RL. You want that to be spreading and being on the correct nodes so that you have the right context on your mind, the correct energy activations lighting up. So then you're going to have the data evolution is generating data from old data and adding new nodes to the hierarchy correctly. And so that's why when you want the activations to correctly be on different nodes and correctly be spread to the correct nodes, you want to have that context, and it's going to light up a similar node based on that context. So you got on your mind dogs can jump, and it's going to correctly spread to the next, what it should be, the node zebras can fly, and then that, because it's similar, and that context is going to correctly light up that one based on all that context, what you currently have heard in the last hour. And so the brain is coming to equilibrium, is trying to spread around that energy and settle. It's always got these things popping up and energy on the things that heard last. So it is talking to itself on its own. It's actually talking. It's not just going to wait for a reply. And it is updating its goal question, talking to itself, deciding when to talk to us, And it's a Turing tape. It's deciding where to look and what to write there based on, like a Turing tape, like like I said, what state it's in, what bit it's on, and it's going to decide what state to go to and what bit to write and where to look. So it's kind of just like you know, it's focusing on what bit it's on, the nodes, and what state it's in is just the node activations, which are basically just the nodes and the positions that are activating your brain, and then it's going to activate other ones that have similar nodes with their positions. And of course, like I told you, also the frequency and the reward and the relation, and if it entails too. If you don't have it, doesn't entail. So all those four are important. And so the brain is so the nodes, like a turntable, it is based on that, it is deciding where to look, what to write, and what state to go to. Now it's just deciding where to look. It can scan a notepad where to look, or it keeps scanning until it finds something and then stop. And it wants to decide what to write there. So it's basically predicting the story at the like GPT-2, but also deciding where to look, and also what sensory to pay attention to if there's a buzzing in the room, and also to pay attention to the words that her last, and also the agenda goals. And so the brain is a turntable, can do anything a turntable can do, so anything a computer can do. And it is so like I said, the four things are it's going to see if it has an answer, and if it doesn't, it's going to see if it can find it on the internet or ask human. If it doesn't, third resort is going to be it's going to try and generate internally. Then fourthly, if it doesn't have enough data, it's going to try and collect more data or try and test in the real world and see what happens. So it's kind of like trying to get some output and also give some input, correct input to get the output, a cycle of that. So you have those four things, steps, and you have the four things I told you: frequency, rank, relation, and if it entails. And then the other four was the attentions. And so it's deciding where to look, what to see it is, what comes next. And so you can see in your brain when you're solving something, you have a question on your mind popping up, you're trying to see what it is, what comes next. And so doing that, there is a evolution of the data. You're coming to an equilibrium, after so much thinking, and you can do your thinking better the more data you have, a quick, faster learning rate. And so so as you can see with the sequence hierarchy here, you have basically all the features that could be on your brain, and they're all built of each other, and they can all relationally, you can jump to one, a few steps away. So it allows you to basically know anything and jump to it, and have also the activations sitting on your mind, and also the popping up questions, agenda, reward, goals. So based on that, you can, you have the structure, the data, and you can go jump to relational ones or ones that come next. You have the activations and the pop-up energy, and this long-term, the frequencies of all the text you've seen, the letter E is all frequent on all the text you've seen in the last 5 years. The word does, very common. And the pop-up questions are this, like every morning you wake up, you have the same question. This long-term learning and the short-term, what you heard in the last hour, activated. This structure, which allows you to go forward or go to related words, and has the traveling activation energy on your mind. It allows you to travel along like a maze and it allows you to answer your questions and come to a new equilibrium based on the structure and the energy. And like I said, all the 2-minute paper videos on the YouTube channel, they all are just, video or image or text or music. It's always just translation or salting a sentence so it's like a different style of like horror or fantasy, or you change it from night to day, or different alternative words like cat was in the farm or dog was jumping into the store or in the outlet or in my room. So you change the, elongate the story, summarize it, shrink it, translate it, entailment, inflate it, make the book different language, French to English, or make the image into 3D, or communicate to another agent 3D wireless, 3D block vision. You can actually show them on the screen what they're thinking. So all those capabilities now. So with this, we can do entailment, translate, and can summarize too by removing, same way as you expand you're going to keep the loved words. As I said in my other video, the frequent words are a double fold. Like when you're predicting the candidate, you want to ignore the frequent, but then when you're predicting the candidate itself, you want to pick one that's frequent. So it's a double-edged sword on that sense. So you want to pick the so you're trying to generate I forget what I was saying here. So you're trying to generate the data. You have, so you can summarize something so that it means the same thing, lights it up, but you've removed words that are either not related to the story, they're frequent, or you remove words that aren't loved, or you remove words that aren't related or are frequent, or you remove words that are just not you can tell somebody, you can say remove the ones that are common or the ones that are related to this. You can activate something, tell your friend to remove all the ones that are related to like farming, and then that person will pay attention to scan through it, and then where to look, the action, the node action, like in here, can be, also to be quiet or to where to look. And because if you have a notepad, you want to decide where to look. If you have a string in here, you can scan along it by the energy flowing through it to the right, so then you can check until you match a word. And then you would want to store it. Well, you're basically going to scan through it, and then you're going to remove certain words, and then you're going to output it here yourself with the word missing. So you'd say, you got dogs were in the farm eating food, and then you're going to hear it, then you're going to say dogs were eating food, you remove the word. Now there's a lot of things like that in the brain, you can do little tricks, but it's using these same things. Now with the summarize, you can entail, translate. So the hierarchy allows you to jump around and allows you to activate related things. You can watch it on the visualization or even interact with it, watch it build more new nodes, spread energy, and it makes sense because you can see the frequency, the energy, the relational, the reward die on the nodes. Now the green nodes here are just the segmentations at nodes because there was a space or a comma. So basically, to make AGI, we need a lot of context input, we need a lot of compute, the context to quantize it, unifies it, shrink it, like I said in my other video notes, and then to extract energy from it, and then to output, to collect more data. The reward is to collect more data, to find similar relations, to get the goal node satisfied, food, breeding, immortality. And so the survival aspect of the AI is to stay alive, to survive, persist, evolution of the data once they come to equilibrium, and we don't like change. So that's the goal of it, is to stay looping, not be harmed. Now, with the brain wants, what we need to do is collect a lot of data, do the context output. So it is basically, what we need it to do is, we want the body, we want the nanobots, but we can do just the internal thinking with the brain, because it's really just faster. Like I said, you can jump in the shoes of other people, you can grow your size of your weapon, you can speed up the simulation, you can run through this and faster than the real world reinforcement learning. So